All right. Let me cover this up. You don't know this yet. Haha. All right. So to solve the system of equations over this finite field, z mod 11z, right? So you got 0 bar, 1 bar, 2 bar, all the way up to 10 bar in our notation. We can solve the system of equations. X plus y equals 7 bar, x minus y equals 10 bar, using usual techniques. So we can like add equations and subtract equations. Adding equations, of course, gives me 2 bar x equals 17 bar, but the multiplicative inverse of 2 in 11 is just 6, right? Because 6 times 2 is 12, which is 1. All the bars. Okay, anyway, so 12 bar x is equal to 17 bar, and then 17 reduces to 6, because if you subtract 11, you get 6 there. And so there you have it. The x value is just 6 bar. Likewise, subtracting the equations gives me 2y bar is equal to minus 3. Again, it turns out I multiply by 6, so I get this equals minus 18. Minus 18, add 22, you get 4. And so there we have y is equal to 4 bar rather. And the solution set is this rather boring singleton. It's just 6 bar comma 4 bar. All right. Now so what I'm trying to say is you can use the usual methods of substitution, adding equations, multiplying by a non-zero number to solve the system, right? But as we've been talking about, you could also use row reduction. So I'd just like to redo this example using row reduction. Try to see how that looks. Hopefully not much different than what I just did here. So the augmented coefficient matrix for this would be 1, 1, fine, I'll put the bars. I suppose if you wanted to, at the start of your problem, say, I'm going to use the notation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 0 for this, I suppose you could do that. I'm just not doing that at the moment to emphasize that we're doing something a little bit different. But of course, notationally it is a drag. All right, so row 2 minus row 1. So row 2 minus row 1, 1 is left alone, right? And 1 bar minus 1 bar is 0 bar. 1 bar minus a minus 1 bar is plus, right? So that's the 2 bar. And let's see here, 10 minus 7 is 3 bar, right? Now, let's see here. Then what? Well, did I make a mistake? No. Oh, sorry, it's 2 minus 1, right? That's minus 2. Yeah. Gotta be careful. And then, okay, so that's the extent of the forward pass. Now, what I would do is I would go from there to, let's say, 6, well, let's say minus 6 bar times row 2, which give me 1 bar, 1 bar, 7 bar, 0, 1 bar, minus 18 bar. All right, so, and then I can do what? I can do row 1 minus row 2, which gives me 1 bar. So now I'm doing the backwards pass. I'm clearing above this pivot. 1 bar, 0 bar, 0 bar, 1 bar. Man, I'm tired of these bars. Minus 18 bar, 25 bar, because I'm subtracting, so it's adding. All right, now let's clean things up. Let's put it in terms of the standard presentation. So that's 1 bar, 0 bar, 0 bar, 1 bar. I'll subtract 22, gives me 3 bar. What'd I do? Uh-oh. And add 22, we get, we get what? 4 bar. All right, so one of these things, it's not like the other. One of these things does not belong. Where did I make the mistake? In the blue or in the black? That's the question. Well, I suppose we can go back and you can know them by their fruits, right? By their fruits you can know them. X plus y is supposed to be 7 bar. 3 bar plus 4 bar is 7 bar. X minus y is supposed to be 10 bar. All right, so 3 bar minus 4 bar is minus 1 bar. Minus 1 bar is equal to 10 bar. So the blue is right. that means I made an error up here somewhere. Let's see where it happened. I added these equations. I got 17 bar, right? I multiplied by 6, but I never multiplied by 6, did I? My goodness gracious. Look at that. So, what is this? So, you see where I made the mistake? It was right here. And so this is what? So I have to multiply that by 6 bar. Now, I don't know about you, I'd rather not multiply 17 times 6. So reduce 17 to 6, and this is really just 6 bar times 6 bar, which is 36. 36 is actually 3. And there you have it. X was 3 bar, and this one too, I just made a mistake earlier. I'm going to actually leave this because I think it's helpful for you to see an example where I make a mistake and see how you can fix it. All right. Well, that's it for this. I'll try to do another example and add a few little videos like this for just single row reductions. Oh, just to conclude. So what this shows, by the way, is that the reduced row echelon form of the matrix 1 bar, 1 bar, 7 bar, 1 bar, minus 1 bar, 10 bar is equal to 1 bar, 0 bar, 0 bar, 1 bar. The vertical line is just decoration, 3 bar, 4 bar. Now, one other use of this you could make is if we were looking at the equation x plus y plus 7 bar z equals to 0 and x minus y plus 10 bar z equals to 0, again in z mod 11, you could also see the solution set from this. This would tell me what? This would tell me x is equal to actually minus 3 bar z, and this would tell me that y was equal to minus 4 bar z if you look at it. And so from that I can get the solution set to this equation would be, what would it be? It would be 0. No, sorry, it would be minus 3 bar z minus 4 bar z such that z is in the z mod 11z. So this would be the solution set like that. So this actually, the single row reduction not only solves the given system that I've written red to start with, we also get a solution to a corresponding homogeneous equation where, you know, if I was to, of course, if I was to tack on a column of zeros at the end, same row reduction. And so we've also at the same time solved this system, which has, I would usually say, an infinite solution set, but in fact this is not an infinite solution set. What does that actually look like? So we're looking at, well, it's still kind of big. Let's see here, rewrite that a little bit. What's minus 3 plus 11 is what? So we've got 8 bar, we got 8 bar, comma, let's see, minus 4 plus 11 is what? 7 bar, and 1 bar. So I got this, scalar multiplied by z is a solution set. There's another way we could write it. And that's such that z is equal to what? 0 bar, 1 bar, 2 bar, all the way over to 11 bar. So if you count the number of things in here, what? Because z mod 11 is a field, you don't get repeats for these numbers. Anyway, you'll get 11 solutions in this case. All right. If we were working over R or C in this kind of thing, we'd get infinitely many solutions. Over a finite field, we seem to get some multiple of the characteristic of the field. So there you go. There's the solution set a little bit more explicitly, not quite explicitly. I mean, I could start listing them. Like there's 0 bar, 0 bar, 0 bar, and then run out of paper all the way out to the last one. Oh man, I don't want to do that. Well, anyway, they keep going. I'm not going to do the arithmetic right now. I got to go to class. Anyway, I hope this helps. I'll try to add a few more of these little examples to supplement lecture. Thanks, guys.